Suppose there is a car driving down a road. Here's my road. This car is driving down the road at some speed. We'll call it VA. Okay? And you're standing on the sidewalk with a stopwatch in your hand, and you're measuring the speed of that car. Okay, so it'd be some distance over time that you measure. So you might say the car is approaching you at some speed, and so you'd measure the distance between the front of the car and your position in the road and see how that position is changing in time. And then you'd measure the change in position, and over the change in time you get the velocity, in which you'd say VA equals this number in meters per second. But what if your friend is driving in a car in the other lane, going a little slower than this car? We'll call it VB. Okay, and they're sitting there in their car, and they have a stopwatch in their hand, and they're measuring the speed of this car. Now they may be considering the distance between them and the car. So the way I've drawn it, with this vector being longer, this car would be getting ahead of your friend in your friend's car. And so your friend would be measuring this. It's getting bigger in time, and so you can get the change in the length of this distance, the displacement, versus their time. And they would get a number. Now that number they would get would be smaller. Their meters per second, whatever number you get, would be smaller than what you get, because this distance here traveled is greater than this distance here, because the reference point is moving in the same direction as the car. So the zero is moving along with it. So that becomes somewhat problematic. Now, in most cases, it really doesn't matter. We usually consider the reference point of this person to be our standard reference point. We call it an inertial reference point, or more so just a standard. The person's not moving. It's with respect to the Earth. Okay, so more so if I was measuring this car position relative to the marks on the road, well, we'd get the same speed because both people can see the position of the car relative to these stationary marks. Okay, so most cases it doesn't matter, but in some cases it does. So like when you're flying an airplane, knowing that the Earth's surface is rotating makes a difference in the time of your flight. And so taking that into account will make a difference. So most of the cases we'll deal with, we don't have to worry about it. But it's important to understand what these perspectives or reference frames can do. And in particular, we'll see how using reference frames allows us to extend some theories that we'll see later in the semester to be more broadly applicable. Okay, so let's try and get a feel for this. Let's go ahead and say, VA is some amount relative to the ground, and VB is some amount relative to the ground. So these numbers would be relative to our stationary or standard reference frame. But my question is, what is VA with respect to B? So I'm going to say, what is VA prime, which would be VA with respect to? WRT means with respect to B. Okay, that's from the perspective of car B. What is that? Okay, well, let's just make some things concrete. Let's say this is 4 meters per second, and this is 2 meters per second. Okay, so if car A is moving 4 meters per second to the right, and car B is moving 2 meters per second to the right, then by what rate is this changing? How much is this distance changing? And the basic idea is, well, this is going 2 meters per second faster than this one, so the space between them is getting bigger by 2 meters per second. Okay? So this would be equal, in this case, 2 meters per second. All right, now, how do we make that more general? What if we just have unknown numbers here? We just want to find it generally. Well, basically, your VA prime is equal to your VA minus your VB, with B being your reference point. VA would be the true, VA is the velocity with respect to a stationary reference frame, and VB is the velocity of the observer relative to the stationary reference frame. And therefore, the perspective, or the velocity of A with respect to B, would just be the difference of the two. Okay, so this is our reference frame. Now, direction matters here. So if I change this up a bit, I have car B moving here with VA, and I have car A moving with VA, and car B moving backwards with VB. Okay, let's be specific again. Let's suppose this is 4 meters per second to the right, and this equals 2 meters per second to the left. Then how fast does this car appear to be going relative to this car? The answer is going to be 6. It's going to be 6 meters per second, because the distance between here and here is changing by 6 meters every second, because this car goes 2 meters this way, this car goes 4 meters this way, so a total of 6 meters every second. And so does this equation work for that case? It does if you include direction. So if we go ahead and choose the direction of A to be positive, so we choose this to be our positive x direction, okay, then this one we'd get equals 4 minus a negative 2. That minus is algebraic. That's just our definition of relating these three quantities. This minus is the fact that this car is moving to the left, opposite our positive direction. And so we'd get 6 meters per second. What if car B was going faster than car A? So let's do another example. Let's say car B is moving at VB, and car A is moving at VA. Okay, both moving to the right. B is now faster. Let's go ahead and say that B is 6 meters per second, and A is 4 meters per second, as it was in the previous two cases. Okay, well, what then is the perspective? Well, just thinking about this should be that VA prime, or the perceived velocity of A with respect to B, ought to be moving backwards at 2 meters per second, because this one's moving faster. So that means this looks like it's going backwards with respect to, if you're sticking your head out the window, you're going to drive by, but if you think you are at rest, then this car is going to look like it's driving backwards. The answer should be negative 2. So if that's the case, then we're going to get, for this case down here, we're going to get VA is 4 minus VB is positive 6, and we get a negative 2. So it works. It works no matter what the frame is. You just have to be careful to choose a direction and then stick with that direction and interpret your results according to that direction. Choosing by plugging in positive here and a positive here, I've chosen to the right to be positive, which means the perspective is that this one's moving negative or to the left. That is a reference frame calculation.